program manager ataupun project manager untuk create satu database, you akan diberi satu borang kosong saja untuk untuk tukar dia jadi satu database, okay? Untuk tukar dia jadi satu database, faham tak? Okay? So sebelum kita boleh jadikan dia, dia ada banyak proses. So sebab tu saya ajar kamu semalam tentang anomalies yang kita tak perlu ada. Okay, dia ada 3 jenis anomalies. Satu adalah, ingat lagi apa anomalies dia? Apa anomalies yang saya ajar semalam? Ingat tak? Ada 3 jenis anomalies. Anomalies means benda yang tak sepatutnya ada. Dan kenapa kita perlu buat normalization dan jadual tu kalau dia bagi format lah, macam semalam saya tunjuk kamu satu format hospital punya format kan. So format tu kita perlu jadikan dia dalam bentuk database. So sebelum tu kita kena normalizekan dia. Okay? Kenapa kita perlu normalizekan dia? Sebab kita tak mau ada data redundancy. That means repetition data. Untuk tu kita juga akan lakukan kita juga pastikan tak ada anomalies dalam, sebab tu kita buat normalization. Kita decompose satu form tu, kita decompose kepada beberapa table. Okay, itu normalization. Kita tak mau ada redundancy data dan kita tak mau ada anomalies dalam table tersebut. Okay, table-table tersebut kita tak mau ada anomalies. Okay, so anomalies ni ada 3 jenis. Siapa masih ingat lagi? Asyad?
Update.
Update. Okay, another one?
Deletion.
Okay, correct. Another one, last one?
Insertion.
Ada delete, update. Another one is?
Insertion.
Yes, there's 3 anomalies. So you shouldn't have error when you are inserting, okay? And then you shouldn't have error when you delete something. When you insert something, you must make sure that you can insert the data. When you delete, it shouldn't delete the whole database, the whole table. You must have the record. And third one is the update. Okay, so when you update, you should be able to update. So all this you should be done. So if we don't want all these anomalies, okay, then we have 3 types of dependency that I discussed yesterday. First one is fully dependent. That means one primary ID. Okay, I share the notes. Okay. I always share full screen, right? Wait, let me share the screen. Okay, I sent to you the latest one. You use the latest notes, okay? Because I always update my notes. And okay, yesterday I stopped here where I taught you on 3 types of dependency. One is functionally dependent. That means example, like you have primary key, okay, employee number. So employee name, salary and city all fully dependent on this employee number. That is fully dependency, okay. And another one that I taught you was partial dependency. Partial dependency means in one table, if there is 2 primary key, you must see which one must take it up. Okay, in above table we have partial dependency. Okay, as stated in non-prime attributes, a student name and project name should be functionally dependent on part of candidate key to be partial dependent. Okay, so since we have 2 primary keys, so we take it out. The student name can be determined by student ID and the project name can be determined by project number, which makes the relation partial dependent. Okay, so we take out the partial dependent when it comes to 2 normal form. Okay, we don't want that. So we break the table into 2 tables. Okay, we take out student ID and we take out project number. So here the project number become foreign key. Okay, and then the last one is transitive dependency, third one. Okay, when there is something here, a transitive function is when changing a non-key column. So this is name is non-key column. That means it is not a primary column, but it affect cause any of the other non-key column to change. So you have to change this when you change the name. Okay, so you have to break the table for further breaking the decompose. We call it decompose the table to further. Okay, so that's what I taught you yesterday. Like here, student detail, we decomposed again into student ID and zip. Can you just wait 1 minute? I have one voice message. I don't know what is. Just 1 minute. 1 minute. Okay. Okay. And I'm going back again. Okay. So today we are going to go on into itu yang saya cover semalam lah. Hari ini saya akan ajak kamu tentang macam mana kita nak decompose dia. Okay, macam mana kita nak decompose dia kepada. Can you see the slide, class? Have any problem seeing the slide?
Boleh, madam.
Boleh ya. Okay. So saya akan ajar kamu the types of forms. Kita akan pecahkan dia kepada normalization ni. Normalization ni kita akan pecahkan dia kepada 3. First normal form, second normal form, and third normal form. Okay, so decomposition. Okay, how can a problem of redundancy and anomaly, okay, solved? So you have to decompose the tables. You have to decompose the table to split a relation into smaller relation. Okay, to split a relation into smaller relation known as decomposition. Okay, itu yang kita akan buat. We will going to break a big table into a few smaller tables. Okay, that's why we call it relation. Relation is table, right? That is normalization, and normalization is actually decomposition of the tables to split a table into one big table into a smaller table. Okay, so this is the following are the various type of normal forms. Okay, kita ada first normalization, eliminate repeating groups. Itu saja. We will look at it. The first one is eliminating repeating group. Okay, who just came in? Who came in? The Narasan.
Yes, madam.
Okay, why you never attend yesterday? You like you attend, you don't like you don't attend, is it? Later you message me. Okay?
Okay, madam.
Okay. Eliminate partial functional dependency. You remember we have to eliminate partial function dependency. And for second normal form, and third normal form, you have to eliminate the transitive dependency. Okay? So I'm going to show you one example how to do this. These are the same thing, the repetition. And the last one is Beyond's code normal form. Okay, so before we start, we go again. What is data normalization? To reduce, eliminate data redundancy. That's all. Always remember, why are we doing data normalization? Because we want to eliminate data redundancy. Okay, through data redundancy, we will be avoiding 3 anomalies. That is insert anomalies, update anomalies, and what else? Delete.
Deletion.
Yes, correct. Delete anomalies. These are the 3 things. We don't want data redundancy and we don't want insert anomalies. Okay, and then for that we do normalization. Okay, we do normalization, and that's why we do normalization. Spelling error. normalization. Why we do, what is normalization? We don't want data redundancy, we don't want anomalies, so we do decomposition. That means break the table, the relation, the big table, the big table, one whole table into few relation. Relation is name of table, entity also table. We break it into few relations so that to prevent all this data redundancy, insert anomaly, we do normalization. We decompose the table. So the normalization is divided into three types forms. One normal form, two normal form, and three normal form. This is what we're going to learn. Okay, and then to achieve these three, we must have one. For one normalization, we must have full uh, functional dependency. Okay, second one, we don't want to have partial dependency. For three normal, we don't want to have, this one we want to have. For second normal form, we don't want to have partial dependency. For third normal form, we don't want to have transitive dependency. Okay, these two we don't want, but we want fully functional dependency. In every table, we want functional dependency. The first one also functional dependency, and we want uh, okay, I will show you what we want in normal form. Okay, the larger table that combines data of multiple entities. Okay, exactly like this. You see, this is a unnormalized table. Okay, this is unnormalized relation or table. Okay, this is large single. So we decompose it. We decompose it into normalized form. Okay, so you see, we decompose. This is the process of decomposing. Composite. We decompose it into three tables here. Okay, but what are the rules? We have to follow the rules. We have one rule for number one rules. Then and one rules, you have single valued atomic data field. Yes, no repeating column group. That's all. Very simple. The first one, definitely it need to be fully functional. Okay, and then it must have this one. It must have single valued atomic field. No repeating column group. Primary key must be defined. Unique column attributes names. Okay, so these are the important thing for first normalization. But first normalization is the easiest one. Okay, single valued atomic. I tell you what is that. Before that, this is the how to normalize database. The database normalization is done by applying the normalization standard defined by EF code. Okay, so he defined the code. This guy invented that. Okay, and he is the one who come up with first normalization, second normalization, third normalization. Okay, he and Boyce, another guy, created another one that is Boyce code. Okay, okay, understand? So far, understand what is normalization? We're going to break a big table into a smaller table. Why? We don't want data redundancy. We don't want anomalies. Okay, what are the rules to follow? These are the rules to follow. You see, this needs single for first normalization. This is the EF code lah. This is the person. Okay, single for first normalization, you need single valued atomic data fields. No repeating column groups. Primary key must be defined. Okay. Second one, you see, for second one, it should be, you must do the first normalization. The first one, you must finish doing the first normalization. Second one, remove partial dependency. I told you, right? Remove partial dependency. If there's two primary key, you break it. Okay. And then the third one, Remove transitive. It should be in second normal form and remove transitive dependency. Okay. And this is one of the example. Okay. This is an unnormalized form, but there is some error here. I'm not telling it's an error, but I try to get this example. They get it in a different way. Okay, this is a student table. Let's say your college also, like this is student ID. This is advanced ID, advanced name, student ID, advanced name, advanced room, class 1, class 2. Okay, you see, you see this class 1, class 2, this one we don't want because it's a repeating data. It's a class, it's a repeating data. We don't want to have no repeating column groups. You see, this is class 1, this is class 2. We don't want that. We want 123, 1238, James 555, 102-8. So we name it as class number like this. This is first normalization. Okay, example, another example I'm showing you here. You see, each field should be atomic, single valued. Atomic means single value. You see, E1, Steve, contact number, got 2 contact number, right? This is wrong, not allowed. You cannot do that. You have to separate. So in this case, your answer must be employee number, name, contact number, and department, right? Okay, so you must have four employee number. Okay, this is E1, Steve, 2533755 something D1. Okay, this is the proper one. This is 1F, 1 and F already. Okay, then you must have E2, then you must have Steve again. Sorry, E1. You must have E1, Stevie again, 64. Now we are taking this number. 64545 something for D1 again. You see, this is allowed. This is not allowed. Can you see that? That's why each field should be atomic. Each column name must be unique. You cannot combine 2 numbers. You can put it in this way. Steve got 2 contact. Okay, this is the proper way. This is allowed. So for second one, E2, Kitty also got 2 numbers, right? So you have to write it separately. 53865 something, D2. And then we have E2 again, Kitty. Then we write Kitty's number again, 24545. Okay, this is D2. So this is normalized form. No, first normalized. You got it or not? You understand or not? First normalized. Class, can you see the first normalized form?
Yes, madam.
Can, okay, wait, I see this one. You have these notes. Okay. So if I give you this one, this table, I want you to do for first normalization. One normalization. What you will do? What will be the answer? Can anyone tell me what will be the answer for this? Is this allowed? Is this allowed?
No.
No. So what will be the answer? You see, this is not atomic. It's not atomic value in each tuple. You see, in one tuple, in one row, dia ada 2 data. Kita tak mau data tu. So, kita boleh pecahkan dia kepada seperti ini. Tapi di sini dia pecah 2 lah. So, saya tak mau pecah 2. Saya nak bagi tahu you boleh pecahkan dia seperti ini. Okay, you boleh pecahkan dia seperti ini. You tengok. You pecahkan dia computer science. Okay, kemudian you letak F1050 Azura Computer Science 118 ni table. So you dah ada dua. So ini satu tuple, ini satu tuple. Okay, ada apa-apa beza? Okay, ini satu tuple. Faham tak? You tengok saya dah pecahkan dia. You tak boleh letak dia macam tadi ni dia not allowed. Tadi ni dia not allowed. Sekarang I letak benda yang sama ni tapi saya jadikan dia row yang seterusnya. Faham tak?
Faham.
Faham ya? So itu adalah first normalization. Ini yang kita panggil sebagai first normalization. Okay, you breakkan dia kepada atomic. Tengok dekat sini dia break. Okay, tengok dekat sini. Dia yang ni dia dah pecah lah tapi it's okay. But I want you to do in this way. Okay, same like here. You see, yang soalan unnormalize ini tadi, yang yang tadi unnormalize ni. Okay, dekat sini you tengok dia pecahkan. Tadi ada 4 row saja kan? 1 2 123 123A James 55. Tapi kelas ni ada 2. 102-8 104-9. So James akan ada 102-8 104-8. Kemudian Smith dia akan ada 209 102. Okay, so yang ini dah first normalize dia. Setiap satu ni dia akan ada satu row. So dia adalah atomic. Dia tak ada dua kelas dalam satu tu. Tapi yang ini seperti ni tak apa, nanti kita akan lihat lagi. Okay, so untuk second normalization, okay, the table should be in first norm. Okay, sekarang kita dah normkan dia dalam first normalization. Okay, kita dah normkan dia dalam first normalization. Sekarang kita akan pergi kepada second normalization where we going to remove all the partial functionally dependency. Okay, the table should be in first normalize. So table kita dah normalizekan, first normalizekan ya. Sekarang kita akan lihat. So the second normalization, it will take out remove all the partial function dependency. Okay, so in this case, it has removed. Oh sorry. Wait. Lama ke you orang tak ada dalam kelas I? Ha? Lama ke?
Lama juga.
Kenapa tak bagi tahu, tak message? I shock ajar lama dah I ajar ni. Ha? Dia just keluar ke macam tu?
Dia terus hilang, madam.
Lama ke?
Boleh lah.
5 minit, 10 minit, sampai mana? Sampai mana I ajar? You orang Alia, sampai mana? Ingat dah?
Sampai second till what? Second normal form.
Second normal form, which one? For this table, is it? This table, is it?
I think another one, madam.
Another one. Okay, this one, this normalization.
Yeah.
Okay, I think this normalization, I think there's some error in this normalization, okay? So I will teach you on this normalization, okay? So you see, you already do the first normalization. That means everything must be individually one. You see, I already do first normalization. That is supposed to be. If you can do it in this way also, it is okay. This is acceptable as first normalization. And second normalization, if you break it into two also okay. If you can do this one also okay. You understand? Okay. So for second normalization, we are removing all the partially dependent. We are removing all the partially dependent. So if we look at here, we will be removing student ID, name, major, grade point. And then we will be breaking into course code, course name, unit, and grade point, because we don't want to have two primary key. Okay, we don't want to have two primary keys, so we break into half, and then from that half we break further. We break it further from, we take out the grade also. We take out the grade because the grade is depends. Okay, so we take out and make this grade as primary key. Can you follow me, class? Are you all there?
Yes, madam.
Okay, if anything, please let me know, because I am off screen, I can't see you all. Okay, so this is second normalization, where you take out all the, you see here, name, major, grade, unit are functionally dependent on student ID. Okay, but partially dependent on the primary key. Okay, grade point is fully dependent on primary key. Grade point, fully dependent on primary key. Okay, that's why they break it into two, because it is fully dependent. Student, but partially dependent on primary key. Name, major, grade, unit. So we leave it here. Okay, and then course code. It doesn't matter, don't read this one. Course name, unit are functionally dependent on course code, but partially dependent on primary key. Okay, so this is what we want. You see, this is the primary key. This is the primary key. So we take out the primary key and we give here we give foreign key. Sorry, this is foreign key. Okay, so we remove all the partially dependent and we make it into 2NF. Okay, so in student ID, name, major, grade, unit is dependent. Okay, so and course also, this is another primary key, and we break it into another foreign key. Even you don't do this, even this one also accepted as, even if you do this for second normalization also is accepted. Okay, in certain case, it depends. Sometimes it depends. It's so difficult for us to teach. It's something like a heuristic. Okay, you should know how to break it actually. Okay, I can show you a lot of examples, but finally it depends on how you break it. Here they break it into grade. Okay, here they break it into grade. So if you want to break it into grade also is acceptable. If not, it is okay. You can just leave until here for your second normalization. This is your first normalization. This is your first normalization. Your second normalization, you take out the two primary keys, course code and student ID, you take it out. Okay, and this one will become your foreign key and this one will become your primary key for this table. For third normalization, you have to add two more tables. Okay, you have to add two more tables, that is your grade, your student major, your course, your grade, and also your unit major, because your unit major is your transitive dependency. So you bring it out. Okay, so that is the third normalization. Okay, and then you have boys code normal form. Okay, so that one is later lah. I am not going to teach you on boys. You all study on boys. Okay, so forget about it. Okay, I'm giving you this table. I'm giving you this table now as an exercise now to do in the class. You can just try to do it. Okay, what I want you to do first is to question. This is your question. I want you to do one normalization first. Okay, you can do it in a group of 3. This is a 15 minutes activity. I want you to start with first normalization and try to do second normalization for this question. Is it okay, class? If I don't give you more activity, you won't know. Can you?
Okay, madam.
Okay, only I always hear Alia's voice only. Tenarasan, are you there? Tenarasan? See, I don't know what's happening to him. He joined the class, after that missing. Tenarasan, are you there? Rishi?
Yes, madam.
Safran?
Ada, madam.
Okay, can we start this one now? I put it in your WhatsApp. Wait, I cannot cut. Okay, where is your WhatsApp? It is not easy, you know. I'm telling you, this is not an easy task. This is the worst part for the lecturer also to teach. Okay. Okay. So you can do that now in a group of 3. Is it okay? Any questions so far? First try first normalization. Class, is it okay?
Okay,
Okay,
madam.
madam.
Okay, I give you 15 minutes to complete this.
Madam.
Yes. Hello?
Buat dalam Word lah.
You boleh lukis pun, tak apa.
Oh, okay, madam.
Okay. I kat sini ya, you orang nak apa-apa boleh tanya. I duduk kat depan you orang je. Sini ada tak rotate. Tak ada. Okay. Okay, ni jawapan dia ya. Etc. tu tak ada apalah. Silap lah I letak kat sana. I bila copy tu I letak. Zafran?
Oh, yang tu tak ada apa ya?
Tak ada apa.
Okey.
Okay, soalan dia mana? Soalan dia sini. Soalan dia yang ini. So, you keluarkan salesperson. Betul. You keluarkan customer. Okay, betul. So, jawapan dia memang betul yang ni. Okay, kita lihat. Kita lihat dekat sini. Okay. Ada yang lagi share, kejap ah. Okay, kejap. Okay, jawapan ni yang Zafran bagi dekat I. Boleh nampak kan skrin? Boleh nampak ya? Ni yang Zafran bagi dekat I. Okay, dia dah break kepada 2 normalization. Betul? Okay, sekarang kan untuk second normalization apa you rasa? Ini betul. Okay, so you break salesperson. So kita namakan yang ini, table ni. Kita namakan table ni salesperson dan kita namakan yang ini salesperson customer. Okay, so kita akan ada 2 table. So samalah dengan jawapan dekat yang I nak tunjuk ni. You tengok dekat sini. You tengok, dia break kepada 2. Dia break satu kepada sales, lagi satu kepada customer warehouse lah. Okay. Sorry, silap. Yang ni. Dia break dia kepada salesperson dan dia break kepada salesperson customer. Nampak tak jawapan dia? Okay tak? So you boleh break into 2 pun tak ada masalah. You boleh break into 2. Kalau you nak letak dalam satu normalize pun saya terima juga jawapan kamu. So you break into 2. Zafran, jawapan you betul. Sama ya jawapan ni. Okay. Ada siapa-siapa lagi? Siapa lagi yang hantar? Merlin is it? No, who's this? Darshini. Okay, Darshini, wait. Okay, Darshini, this one also is acceptable. Darshini dia hantar dekat I penuh. Okay, saya biasanya saya accept juga jawapan ni ya. Tapi kalau you boleh jadikan dia this is Darshini's answer. Kalau you boleh jadikan dia lagi kecil lagi baguslah untuk dua table tu lagi bagus. Tapi if you do, dia mestilah atomic. I accept this answer also because you already broke it into atomic. Satu tuple, satu value saja dalam tu. Bukan dua value. Okay, this one also can be considered for one normalization. Biasanya sebab saya ambil daripada internet jawapan dia, so diorang ni advance sikit lah. So apa diorang buat? Diorang buat dalam bentuk ni macam Zafran buat. Okay, dia break kepada 2, salesperson dan sales customer. So kalau kita lihat yang ini dah first normalization. Second normalization dia nak keluarkan partially dependent. Okay, partially dependent kalau you lihat dekat sini dia ada yang ini dia biarkan. Salesperson ni dia biarkan dah. Dia dah tak ada apa-apa. Dia fully functional. Dia first normalization is complete semua with salesperson number, salesperson name and sales area depends on salesperson number. Okay, nanti dia akan break lagi lah. Okay, sekarang kita lihat salesperson customer ni. Kalau kita lihat table ni, untuk second normalization kita tumpukan kepada table ni di mana apa yang kita boleh break. Kita tumpukan kat table ni. Siapa boleh bagi saya jawapan untuk second normalization? Who can give me any answer for second normalization class?
Warehouse number.
Warehouse number, customer warehouse number. Okay, correct. Warehouse number. So we break into 2 things. One is sales, another one is warehouse. Correct or not?
Correct.
Sorry. Customer and warehouse. Correct or not? Because we have customer and warehouse together, so we break it into 2. Same like this, you see? We break it into customer and sorry. They break it into customer and okay. Break it into customer and sales. Again, this one customer and sales. Warehouse also, customer warehouse, and they put it sales here lah. You see here, they put it customer warehouse where they take the customer number because we don't want 2 primary key here. So they take out the customer number and also they take out the customer person. So they put the customer person, the salesperson under sales and the customer under customer warehouse. Okay. So you have 2. So the third one, what do you think they will break? Which one? Which table do you think they will break? Which table you think they will break? Which table? For third one.
Oh, warehouse number.
Yes, warehouse. So this is the one. They break customer warehouse. So I start again. I think you're quite a bit confused. So this is your second normalization, first normalization where you break it into salesperson and salesperson customer. Okay, so this salesperson is clear, nothing to be normalized again. Okay, first normalization is perfect. So second normalization, we have 1 2 primary key here. So we have to break this one. So we go into here, we go to salesperson and we break it into two, that is customer warehouse and also sales. We break it into two. So we have salesperson number. So because just now we don't want partially dependent, we don't want two primary keys, so we took it out. So we have customer warehouse and sales. So now sales is customer number and sales amount depends on salesperson. But in customer warehouse, we can also break it further because it has a transitive dependency, because if they change the warehouse number or warehouse location, this is called uh, transitive dependency. So we can remove this, we can make it as this, where we change into customer and warehouse. We break, this is the third normalization where we take out the transitive. We do not have, we only have foreign key here. We don't have any primary key. So if they change location, automatically the warehouse location will change. If you change in the parent, or you change here, okay, if you change here, then it will be automatically changed. Okay, so that's how finally you will get this. You will have salesperson, you will have sales, you will have customer, and you will have warehouse. So this table is ready for you to implement into a database system. You can start programming this actually. You understand or not? You can actually start program this. So this is all I wanted to teach you for today. Actually, that's all my notes. All this I tambah. I got one work for y'all. You understand or not? Class? Roughly can see or not? A bit can see or not?
A bit
I don't,
boleh.
okay,
Can.
I
Not
think
very clear, madam.
tak clear sangat.
Madam,
Really?
may you repeat the third normalization form? I confused already.
Okay,
Yeah.
okay. First normalization, you must have all the no atomic value. That means everything must be a single value column. Exactly like this, what you have done. Okay, this etc. is nothing. This is a typo error, etc. That means they're telling you can put more. That's all. Because I took it from the internet. I took so many sources for y'all to show y'all. So the first normalization is either you can leave it in this form, break it into two tables is acceptable, or you leave it like how Dashini has done for first normalization. You break everything into a single, no atomic value. That means every tuple will have a single value. This is acceptable. This one also is acceptable. You already break it into two tables, like one of the example that I shown you. Okay. After that, you see the second table. This table we know salesperson and sales area depends on the salesperson's number. So we can't do anything on this. It does not have any partial dependency. The second one, yes, it has partial dependency where your sales number and customer number in one table. Okay, so that means salesperson number also depends on customer name, warehouse. So we don't want that. So what we do, for second normalization, we remove the partially dependence here. So we take salesperson and we break it into two tables, that is salesperson, customer, warehouse, because here we see we have warehouse and also we have sales. So we break it into two. We have customer warehouse, we have one customer ID. We take out the primary key. So we know for customer warehouse, customer number the customer name, warehouse number, and warehouse location depends on the customer number. And salesperson, we have one primary key which will make customer number here will become foreign key. Okay, it is not depend directly. Okay, so there's no partial dependency, so we break it. Here, the customer number become foreign key, not primary key. Okay, and then the amount, the customer number and the amount, we break it. So that is second normalization. Pretty, is it okay?
Yeah, okay.
Okay, the last one says if you change the location, any location here, okay, one will be this is a primary key. This will be your this will be your foreign key. Okay, so this will be your foreign key. So any changes done here, automatically it will show. If it is change this to 3, so it knows that it is Bismarck. So when it was in second normalization, okay, when it is in second normalization, this part we call it as transitive dependency, where any changes anywhere here, you have to go. If you change 3 here, you see 3 Denmark, there's a repetition also, 3 Denmark, 3 Denmark. So what we do, we take out this part. Okay, you see there is also redundancy and it's also transitive dependency. So you pull it out, and make it another table. Okay, you make it another table. So this is your third normalization. So finally you will have 4 where you have salesperson, which you got it from beginning. Okay, and then you will get sales after the second normalization, and you will get customer and warehouse after the third normalization. Okay, so this is your answer for the third normalization. I will give you this this answer also. Okay, after this I will just compile only this part and give you. I'll put it in the wait, let me copy, then I'll forget one. Copy, I put it in different slide and okay, this is also task for you, but I have prepared with the answer. Okay, I'll pass it to you in a while. Okay, so so that's what I can. I tried my best to put it in a way that you can do it. Okay, I am giving you one simple exercise here. This is very direct exercise. It is just need for one normalization, you need one table, for two table, for three table. Okay, because I've given you very simple one for you to do for normalization. Okay, so what I want you to do, it's also your task now. It's either you do it now or you can do it on Thursday. Because there's no class on Thursday, I'm on leave. Okay, so it's up to you. You want to do it now and hand over to me on in today, or you want to hand over to me on Thursday. I make it as your task and you submit to me on Thursday. Is it okay?
Okay, madam.
Thursday tak ada kelas madam?
Thursday tak ada kelas, Tuesday public holiday. So first part of this normalization dah habis. So kita dah belajar dah apa tu normalization. Kita dah belajar anomalies, kita dah belajar data redundancy, dan kita dah tengok juga normalization punya proses. Saya akan bagi video lah untuk kamu share. Saya akan bagi beberapa task tau untuk kamu. Okay, yang ini task pertama. Okay, saya akan bagi lagi new task. Yang ini task pertama. So you nak hantar bila? Khamis ke hari ni?
Khamis.
Okay, Khamis masa kita 2 hingga 4. So saya bagi you hantar Khamis. Berapa hari bulan? 14 kan?
Madam, good work, right?
4 PM. of group 3x per group. Okay, this is one. Another one, I want you to find for B, B, C, F. What is B, C, F? Buoyant's code normal. I want you to find video and do a simple chart on presentation on this. Okay, you just do. I'm not going to ask you to present, but you just do one slide presentation. Don't follow my slide. Okay, I want you to see videos, okay, and summarize this one in one slide. Okay, this is second task. This is first one. Okay, this is second one, and you have third one also. Okay, this is the third one. This is the third one. I want you to find minimum per group 1, 2 videos or slide presentation on 1 and F, 2 and F, 3 and F. Okay, I want you to then 2 videos, or you can pick 2 videos or one slide, or one video and one slide, or 2 videos, doesn't matter. Faham tak? You boleh ambil 2 video ataupun satu slide, satu video. Okay, never mind. I give you any slide you can download from internet. A lot of things on 1 normalized, 2nd normalized, 3rd normalized. So you summarize juga. You summarize satu video, satu slide. Satu slide presentation. You cari dalam Google, ada banyak. Satu slide. So you bagi tahu, kalau tak cukup satu slide, you boleh bagi I 2 ke 3. Tapi you kena bagi tahu contoh lah. No need slide lah. One video, one summary lah. One video, one summary. One video, one summary. One slide presentation, one summary. Summary means you kena tunjuk dekat I macam mana dia buat first normalization, second normalization, third normalization daripada unnormalized. So you akan ada 2 ni. Faham tak? Kelas faham tak? Yang ni 2. First one, you see I dah bagi unnormalized table. Okay? You buat, can you hear me class?
Juga madam.
Okay, first one. Tenarasan, are you there? No. Tenarasan? Just now I call you, where you went?
Go to toilet, but
Sekejap ada, sekejap tak ada. KitKat ke you? Ha? Tenarasan?
no, madam.
Bukan KitKat. Dan Panther. Okay? So this is your first task. Okay? Remember, this is for your Thursday task. This is your first question. This is question number 1. Do in 3 per group. Okay? Because I'm not here, so I'm giving you work and you have to submit to me on this. So this one you have to do first normalization, second normalization, and third normalization. Your second task is I want you to review one video and one slide presentation. You go into anything you find. If you cannot find a slide, you do 2 videos also, it's acceptable. On one normalization, second, third. And summary, you have to show me the table. Unsummarized, unnormalized, first normalized, second normalized, and third normalized, how they do that. If you are looking at slide presentation, also same thing. Do unnormalized, and then first normalized, and third normalized also you do. And then I want you to see video and summarize on voice code normal form. This one I might ask any one of you to present because I never teach this in class. So this one, I gamble lah. This is presentation. I can choose any group. I'm not going to waste my time and choose a lot of groups. Only one group I'm going to choose, but you see who's the lucky one. Okay, but everyone must do. If you don't do only, I will call you. So make sure you send to me. So now I'm going to put it.
Nah, madam.
Yes.
Yang soalan 2 tu,
Okay.
lepas dah tengok video dengan tengok slide presentation tu, lepas tu kita nak kena buat apa? Presentation ke macam mana?
Tak payah. You buat summary. You buat macam tadi I buat lah. You tengok, nampak tak? You tengok. Yang ini unsummarized. Unnormalized. Okay? So ini first normalized jawapan yang ini. Yang ini second normalized jawapan ni. Yang ini third normalized. Dan finally ini adalah jawapan terakhir dia. Faham tak?
Buat dalam Word madam.
Oh, you boleh buat Word, you boleh buat PowerPoint. Tak kisah.
Okay, madam.
Okay, the front. Anyone else? Any question? Sailesh, why so quiet today? Not around.
Yes, miss.
Oh, yeah.
I am.
Okay, understood.
Understood, miss.
Understood, huh? Okay, so that will be your task. Okay, your task. Well, I put your task just now. Missing already. Let me find your task. Banyak sangat slide I ni. Sampai I pun tak tahu mana. Okay, this one. This one and this one. Okay. Nurul, any question?
Madam.
Tak ada. Adib Omar?
No, madam.
Adib? No. So I'll put this in CDOS and this latest notes also I will put in your slide, your WhatsApp. Okay, so this is only one part of topic 3. You know, there's another part coming. Okay, that part is a bit better. The other part is a bit better where from this table, we will be developing the relationship. We will be developing a relationship between this. Now it's nothing, right? Now it's nothing, right? Later we will put a line. Later we will put line for each entities. So we have 4 entities. So there's 2 models. We call it chance model. Another one is cross foot. So I will be teaching you both. So this is the toughest part of database because you are going to you coming out with a table. You know, it is not easy. That's why this one is normally the project manager. The strong people of database will normally do that. Okay, that is their task. They go to they try to find client. They go to old folks home. They inquire what are the things they need to be built in their database. So they will come. They will do normalization, and then they will use this ERD diagram. We call it ERD diagram. ERD diagram. We have 2. That is cross foot and chance model. You use that, and finally only the programmer will program, use SQL to do the database, full database. Okay, and then only the DBA, database administrator, will support this. You understand or not? Okay, this is the basic one, you know, from a scratch form, the form that UEC, form yang UEC tu kita jadikan dia, kita nak jadikan dia database. So ini adalah proses-proses dia. Salah satu proses, very simple one. That's why I want you to see videos. Okay, I want you to see videos. Is it okay or not, class?
Video tu boleh cari mana-mana madam.
Mana-mana pun boleh. Ada banyak lah, you cari dia, banyak video dia. I tak nak bagi link lah, I nak you orang cari, faham tak? Tapi jangan copy lah, video tu pun janganlah pergi copy. You carilah, Google you kan dekat your hand kan. You can find one. Yes or no?
Yes, madam.
Yes, okay. Your next week is 7th week. The following week will be 8th week. 8th week you will have quiz 3. You will have lab task 2. You will also have case study 1. Your case study 1 is exactly like this. Okay, we don't give you like this unnormalized box. We give you a task like this. You see, I show you one of the tasks that we discussed today, how to give you, okay, like this. This is the task that we will be giving you for case study 1. You want to develop a database system for your company. Therefore, you need to analyze all of the records that you have. So you have to, what do you think? What company you want to have? You nak buat tudung ke? You nak buat spare part kereta ke? You nak buat you nak buat what else? Library system ke? Okay, so you have to come up with your own system. Okay, you have to come up with your own system, and then you lump sumkan table to you kena dapatkan unnormalized to you tengok you kena dapatkan daripada unnormalized to third normalized table tersebut. Then from there you have to use ERD diagram, that is model, chance ataupun crowfoot. Okay, that is your case study 1. Okay, your case study 2 pula will be from case study 1. Okay, you dah dapat semua tu, you create database untuk table-table yang you create sendiri tau. Kami tak akan bagi apa-apa. You create sendiri. Okay, contohnya macam ni kan. Macam ni, yang ini apa? Ini customer warehouse. Mungkin projek dia ni customer. Ini dia punya sales lah. Yang ini dia punya sales. So dia ada salesperson, dia ada customer number, dia ada warehouse number dan location. The sales amount. So you can break it into it. You can break into it. You come up with your own unnormalized form. Then first normalize, second, third normalize. You punya business tu. You yang akan buat macam Air Asia booking or train booking. Contoh contoh I tunjuk lagi. Macam ni. Contoh dekat sini ya. Contoh dekat sini, projek dia bagi tahu hospital management system. Okay, apa dia nak? Okay, apa yang biasa dia akan ada department. Yang itu satu entity. Dia akan ada doctors. So you boleh lamsamkan dia sebagai unnormalized form. Okay, kemudian dia akan ada doctor on call, dia akan ada pad entry semua. Okay, kemudian dalam contoh ni dia bagi ERD diagram. Okay, dia yang ini chance model lah. You tengok untuk department, department name, department location, facility. So untuk doktor, doktor number, PH. So yang ini dah normalize lah. Yang ini dah normalize. So you akan buat sampai sini. Tajuk lain yang you boleh ambil, ini contoh ya. Tajuk tajuk lain yang you boleh ambil adalah railway reservation. Okay. So you tengok reservation, train list, train status, passengers, booking, cancel. So ini contoh. Nanti bila you orang nak buat case study 1 tu, saya akan bagi contoh ni dekat you. Okay. Ni contoh ya. Contoh you boleh ambil train railway reservation or bus reservation or flight reservation. So you boleh ubah. Jangan pilih yang sama. Saya bagi contoh ni sebagai reference untuk kamu saja. But you develop your own ERD diagram. But before that, one step not here. That is your first, second, third normalization. Okay. And painting higher business. That is one. Tengok dia bagi form saja, customer rental, artist report. So you have to come up with a database. And then case study 4, the work relation. So dia dah bagi table dekat sini. So dia suruh you normalizekan dia, how many table you can come out with. Okay. And then this is another one, company. So many others. That is how you use this normalization. This is the first part of your database development. Okay, so I will open up your CDOS now. No break lah today because I'm going to end the class today quite early, right? So how much I teach you also you have to practice. That's why I've given you some task for you to do. Okay, and the second part I will be teaching you. Maybe I will ganti lah this Thursday's class, since I already give you assignment. I think I won't ganti lah. No need ganti unless if I need your time, I will let you know in future. If I cannot finish the syllabus. Is it okay?
Yes,
Okay, madam.
Yeah. Okay, so I'm going to give you this one is your task for Thursday. Asynchronous class. This one for your asynchronous class. So I'll open up in the CDOS and you have to submit to me on 4 p.m. 3 packs per group. So maintain this group lah. So we will have 8 group. Maintain this group. Is it okay? Maintain this group for your case study 1, case study 2, lab, everything. Maintain the same group. Okay? So any issue? Kelas
Tak ada, madam.
English tak ada. Kalau tak ada kerjaan, okay, you orang boleh bersurai lah. Nak bersurai ke tak nak bersurai? I bersurai pun ada yang tak pergi-pergi pula. Tak nak tinggalkan kelas ini. Okay? Ahmad Akmal, are you there?
Yes, madam.
Ahmad Akmal?
Yes, madam.
Okay. Can hear you but very slow. Suyuf? Any question? Suyuf?
No, madam.
No. Brittany?
Now,
No. Clear?
clear.
Okay. Abhinaya?
Yes, ma'am.
Okay.
Yeah, okay.
Okay. Merlin?
Yes, ma'am.
And Kavina? Kavina? Kavina went for tea break, Kavina. Okay. So, I will meet your, oh, madam, line slow. Okay. Another person is Huma. I wanted to ask. Darshini?
Yes, ma'am.
Okay, Darshini?
Okay, ma'am.
Okay. So, that's all for today. So, I will open up now itself the question. Now I'm going to do the CDOS. So, I will save this file as assignment for Thursday. Okay. 14 April 2022 assignment. Okay. So after this, I'll open up the CDOS. Okay. So you all can go out now.
Thank you, madam.
Okay.
Thank you,
Thank you, madam.
Happy lah. Happy holidays for me.
Thank you, madam.
Bye.